Hello students, my name is Yash Baheti. I am a BTech from IIT-JEE. In this lecture series, we are going to study one of the important topics of 11th class and one of the important topics of conic section as well, which is ellipse. Now, why we are studying this ellipse chapter as an important chapter is because many of the questions will come by combining the concepts of ellipse as well as other parts of conic section. In this part, we are going to study the basics about the ellipse, how it can be generated, where do we observe ellipse, and its general equation, as well as the general terminology of the ellipse. So let's start. Now, ellipse. We all always intend to know that where do we encounter the elliptical shape? I mean, it's not that common, or from where this shape would have come from. Now the very basic example that I would like to give you, that from where does this ellipse shape comes, is you can see on the board that there is a ball revolving in an elliptical orbit. So this is an elliptical orbit, it looks like this, and this ball is revolving around this. This ball is actually our Earth. As we all know that Earth revolves around the Sun, so this is our Earth. Now where is the Sun? The Sun is not at the center. The Sun is somewhere here. So in the elliptical shape, Earth revolves around the Sun, where Sun is somewhere on the side. Now this was an example. Now let's see that how can we generate an elliptical shape. So as we all know that ellipse, hyperbola, parabola, straight lines, pair of straight lines, they all are termed under conic section. That means they are one or another part of a right circular cone. So imagine that this is a right circular cone. Now I am going to cut this cone with this plane. The orientation of the plane and how you cut it decides which shape you are going to generate. So if I cut this cone with this plane in this direction, I am going to get a circle if you look from the top. But in order to generate an ellipse, I am going to tilt it so that it becomes perpendicular to the slant height of the cone, and then I am going to cut it. If you cut the cone and remove the upper part, also remove the lower part, you will see that there is a straight line if you see it from the side. But if you look it from the top, you will see that an ellipse shape is coming. Now with respect to the axis of cone, ellipse shape is going to look like this. So this is about how you can visualize an ellipse and how it can be generated. Now let's see the mathematical part of it. Suppose that there are two perpendicular lines and we have a point P. Now this point P is the variable point, this point is going to move. Now what the definition says is that ellipse is actually locus of a point, locus of this point P, which moves in a plane such that the ratio of its distance from fixed point, remember fixed point, S is our fixed point, which is known as focus. And from a fixed straight line, this straight line is fixed straight line, we call it directrix. So the ratio of distance from a fixed point to fixed straight line, that means distance from fixed straight point is SP, distance from fixed straight line is SM. So SP divided by SM is always constant and is less than 1. So this ratio is always constant and this ratio is called as E, that is the eccentricity of ellipse. And this E is always going to be less than 1. So this is the definition of ellipse. Now we have known the ellipse, how it's shaped. Now there are various general terms and various things that we need to look about. For example, an ellipse, as we know, looks like this. C is the center of ellipse, which is in general 0, 0, but this is center. It can be anywhere else as well, there is no problem, but in general we take it here. S and S dash are two focuses. That means the coordinate of S dash and S will be AE, 0 and minus AE, 0, if C being 0, 0, that is the center. If you analyze that how I have written these S and S dash coordinates, you can clearly say that AA dash is actually x-axis, but here we call it as major axis. Now if a dash is a major axis, the coordinate of this point a dash is a comma 0. The coordinate of this point a is minus a comma 0. So your major axis and its extremities. These extremities are also called as vertices of ellipse. Similarly, we have bb dash. bb dash is actually minor axis. Now how do you identify which axis is major and which axis is minor? Obviously, whichever axis is bigger, that is the major, and whichever is smaller, that is the minor. For example, major axis here is 2a, and the coordinate of this point b is 0 comma b, and the coordinate of this point b dash is 0 comma minus b. That means the length of minor axis is 2b. Now if 2a is greater than 2b, then aa dash is major, or vice versa. Let's move. That means the distance of C from S dash is A both ways. It's just the direction that is differs. Now, these two lines are called as directrix. So, N dash, Z dash and NZ, these both are directrix. Now, if they are actually a straight line, so what is the equation of straight line? The equation of N dash Z dash is x equals to a by e. The equation of nz is x equals to minus a by e. That means the both straight lines are actually at a by e distance from origin. But it's just that their direction has been differed, so they have been written like this. If we move, there are two more things that I can draw. First thing is any line that is perpendicular to your major axis. If this line, let's say L, if this is perpendicular to your major axis, then L is called as double ordinate. But if this L passes through any of the focus, if this L, which is perpendicular to axis, and if it passes through any of the focus, let's name it as L dash, then L dash will be latus rectum. So what is a latus rectum? A latus rectum is a double ordinate that is passing through focus. Now one more important thing that in which we are interested is what is the length of this latus rectum. So how can we find the length of this latus rectum is we know that the equation of latus rectum is either x is equals to AE or x is equals to minus AE. These two are the length of these two are the equations of latus rectum. So what we can do is that when you put x equal to a in the equation of ellipse and when you solve, you are going to get 2 points. What are you doing? When you are satisfying this equation of straight line with the ellipse, you are going to get points of intersection. So you are going to get one point as this point and another point as this point. And with the help of distance formula, you can find out the equation, the length of latus rectum. So I am going to tell you the direct result. The length of latus rectum is actually b square by a. That is half of it. If I multiply it with 2, then this is the length of latus rectum. 2b square by a is length of latus rectum. So this is all about the terminology in the ellipse. Let's move. Now we'll move to the standard equation of ellipse. What is the standard equation of ellipse? Standard equation of ellipse is given by x square by a square plus y square divided by a square of 1 minus e square is equals to 1. Now to this a square of 1 minus e square we have termed it as b square. So that means b square is a square 1 minus e square. Wherever e is actually the length of latus, e is eccentricity. So what is a? A is actually your semi-major axis, length of semi-major axis. What is b? Length of semi-minor axis. So a is the semi-major axis, b is the semi-minor axis. Eccentricity of the ellipse, as I have told you, b square is a square of 1 minus e square. So if you solve it for e, you will get e square as 1 minus b square by a square. You can take the root. We know that an ellipse has two foci and two directrices. So this E is going to come as plus minus. Obviously eccentricity cannot be negative, but this plus minus shows that if there is one focus, then corresponding to the negative one, because coordinate can be negative, so corresponding to the negative part there is one more focus. And if there is x equal to a by e as one of the directrix, then the corresponding second directrix also has a coordinate but of negative sign, x equals to minus a by e. The length of lattice rectangle that I was talking about, if you put x equals to a here and if you solve for y, you will get two coordinates of y. That means those two are the two extremities of lattice rectangle. And by using the distance formula, you can solve it. Let's continue with the standard equation of ellipse. Now there is one more thing which is called as tracing property. How you can trace the equation of ellipse, or how you can trace the equation of ellipse in general, how you can draw an ellipse to its perfect form in general. So I'm going to tell you that method. Now, what is the focal distance of a point? First of all, we need to study that focal distance of a point is distance of a point from the focus. It's very obvious. Suppose that we have this as ellipse. Now this is the point P, the point that is moving on the ellipse, and these are the two focuses. One is S dash and one is S. So if I want to write what is the distance of this point P from this focus S dash, then I am going to write as S dash P is equals to E times P n dash. So we know what is P n dash. P n dash is actually, this distance is A by E and this distance is X, because we know the coordinates of P is X comma Y. So obviously this much distance is X. So P n dash will be A by E minus X, and E times P n dash is E times A by E minus X. That is, if you multiply E inside, you will get A minus EX. Similarly, we can do this on the other side. PS is going to be equal to E times Pn. So again, now your X is here and this distance is again A by E. So our Pn will be X plus A by E, and again E is on the outside because it's E times Pn, so that will be A plus Ex. If you join these two focal distances, that is S dash P and SP, that is the distance of point from focus. If you join these two distances, you will see that this distance is always constant and it's equal to the length of major axis, that is 2A. So what I am trying to say is that no matter where this point P is, its distance from both the focus S and S dash is always constant. So if you put two pins here, just put up two pins, take a thread of any length which is greater than S dash, tie both the ends of rope at S and S dash, and remember that your rope has to be bigger than S and S dash. So that means the length of your rope is major axis. If you put a pen with the rope and if you draw the figure with your rows properly stretched, then you will get a figure which is a ellipse. So this is the tracing property of ellipse. Always remember, sum of focal distances of any point on the ellipse is equal to the length of its major axis. So this is called as tracing property of ellipse. Let's move to the other form of ellipse. This ellipse, you could have seen that this ellipse was a kind of horizontal because its major axis was x-axis. What about if the ellipse major axis is vertical, like this? The equation remains same. As I told you, the only difference is that now this length 2b from here to here will be greater than this length 2a. That means 2b is greater than 2a, or you can say that b square is greater than a square. And the major axis and minor axis of ellipse still lie along y and x axis, but now the major axis lies along y axis and your minor axis lies along x axis. The length is against 2b and 2a, but your things will change. The center is here. The coordinate of focus now will be 0, be and 0, minus be. This point is 0, b. This point is 0, minus b. This point is minus a, 0. this point is a comma 0. So most of the things are same, just that the coordinate of focuses have been changed, and straight away this will be one of the directrix, that is y is equals to minus a by e, and one directrix will be there on the top, which will be y is equals to a by e. Now the directrices that I have told you, eccentricity, again you just need, whatever you are doing, you just need to interchange a and b, because your focus is now changed. Okay, you can turn this and you can still make it our regular ellipse whose major axis is x-axis. So that's what I'm saying, that if you interchange a to b, or if you can rotate in, both the things are same. So its eccentricity will be root of 1 minus a square by b square, obviously because now b square is greater than a square, and the length of semi-latus rectum is a square by b. That means the length of latus rectum is twice of a square by b. If the center of ellipse, now this is important thing, this is for the previous ellipse as well, for all the ellipse, or nearly for all the figures. If the center of your ellipse has changed and it has been taken to h comma k, then the axes are parallel to x and y axis. Remember, your axis has to be parallel to x and y axis. It's just that you have taken the center towards some another point, or in other words, if you can recall, this is just the shift of origin. If you shift your origin to be h comma k, and if you call it to be a new origin, then going by the fact, your x will transform into x dash. Okay, again your capital X dash will be what? X minus h. This is your new origin, and this is your origin in terms of old coordinates. Y dash will become y minus k. So if you replace, now what is our equation? Our equation has to be x dash square by a square plus y dash square by b square is equals to 1. This is the equation in new coordinate axes. If you take it to the old coordinate axes, you have to replace x dash and y dash. So x dash will become x minus h, y dash will become y minus k. So as I have told you previously, that you can change the center according to your will. So this is the equation of ellipse when its center has been changed. When its center is not the origin, but now its center is some h comma k. So let's check our concepts, how well we have studied. This is the checkpoint number 1. Now what we need to do here is find the equation of an ellipse having major axis along the line y is equals to 4. So its major axis is along line y equal to 4. So let me draw, let's say this is its major axis and this line is y is equals to 4. Major axis along y axis, remember this point, that means this one is tilted one. And the point 2 comma 1 is one of the extremities of its minor axis. That means 2 comma 1 is the extremities of minor axis, and the ellipse is like somewhat like this. Okay, this distance, that is the perpendicular distance from this point to this point, is your semi minor axis. Its eccentricity is given as 1 by 2. So we need to find out the equation of ellipse. Now in order to find out the equation of ellipse, we need to find out a and b, and we know the relation of eccentricity. Now if this point is 2 comma 1 and we have this y is equals to 4, we know that y equal to 4 line and a line that is minor axis, they both are perpendicular. That means this perpendicular distance is your semi minor axis. Equation of line is y minus 4 is equals to 0. So the length of perpendicular from 2 comma 1 to y minus 4 is 1 minus 4 divided by 1 square root and modulus. This is the length of semi minor axis, or let me call it as a. Let me say it as a. That means a is 3. Now why I have said it as a, it's because this line, which is actually parallel to x-axis. So if a is 3 and if this is parallel, that means I am taking b as my semi-major axis, because this is semi-minor axis. I am taking b as the major axis. Now I know the relation, that is b square is equals to a square 1 minus e square. Sorry, I have done it the other way. It's a square is equals to b square 1 minus e square. Let's do it again. Now let's check our concept on this. What the question says here is that find the equation of an ellipse having major axis at line y is equals to 4, major axis at y equals to 4. So suppose that this line is y equals to 4. Here major axis lies here, and 2 comma 1 is one of the extremities of minor axis. So let's say this point be 2 comma 1, that is the extremity of minor axis. Your ellipse will somewhat look like this. And this, the length of perpendicular from 2 comma 1 to y equal to 4 will be your d, that is semi-minor axis, because we know that both the axes are perpendicular. So y is equals to 4, 2 comma 1, I can easily find out b by our length of perpendicular formula, that is y minus 4. So 1 minus 4 divided by root of 1 square, that is my b is 3. So we have got our b as 3. Now we know that b square 1 minus e square. Let's check now our concepts on this. We know what we need to do is that find the equation of an ellipse having its major axis along the line y equals to 4. Let's say this line is y equals to 4. Y equals to 4, that means parallel to x axis. That means it's a regular ellipse. And 2 comma 1 is one of the extremities of minor axis. So let me complete the figure. This is what our ellipse looks like. If 2 comma 1 is one of the extremities of minor axis, that means if I draw this line perpendicular to this y equal to 4, this length will be my semi-minor axis length, that is b. I can easily find out, as I know the perpendicular distance from a point to a line. Your equation is y minus 4 is equals to 0. We have point 2 comma 1. So b will be mod of 1 minus 4 divided by root of 1 square, that is the perpendicular distance formula. So your b is 3. Now we know the relation between b and a, that is b square is equals to a square 1 minus e square. So our b is 9 and our e is 1 by 2, it's given. So 9, b square is 9, a square 1 minus 1 by 4, that is 3 by 4. So my a square is actually equal to 12. I have got a square, I have got b square. Now I need to find out the center. If I got the center, I can write my equation in this form: x minus h by a square plus y minus k whole square by b square is equals to 1. So I need to find out this point h comma k. If this is line y equal to 4, then that means that the equation of minor axis will be x equals to lambda. And this line passes through 2 comma 1, that means my lambda value is 2. That means this line is x equals to 2. So clearly my h comma k from the point of intersection of these two lines will be 2 comma 4. The equation that I want to find out is x minus 2 whole square divided by a square, that is 12, plus y minus k. K is 4. Y minus 4 whole square divided by b square, that is 9, is equals to 1. This is the required equation of ellipse. You can see that the center is not at 0 comma 0, but I have still managed to find it out. So you just need to remember the basic concept that the axes are perpendicular, and the perpendicular distance from one point or from the extremities of axis to this another axis will be the semi-major length of that axis. Let's move to one more question and check our concept. We need to find out the focus of ellipse whose equation is given by this. Now here we know the equation and we need to find out the focus. But I can clearly see that this equation is not in a regular form, not in the general form. So let me first find out the equation in general form. Its equation will be represented by x plus 1 whole square. I am dividing by 225. So 225 and then y plus 2 square. 225 divided by 9 is 25 and 225 divided by this is 9 is equals to 1. So this is the standard equation of ellipse now. I can clearly see that minus 1 comma minus 2 are my center. So if I draw the ellipse, I know the coordinate of center. I know the coordinate of center. There is one thing that we need to note. 25 is greater than 9. That means it's this B is the major axis and this A is the minor axis. That means this ellipse is actually not like this, it's like this, because this B or B is actually 5 and A is actually 3. So that means this ellipse is 90 degree rotated. Now if this ellipse is 90 degree rotated, that means we have B as 5, A is equals to 3, but because this is the case, our formula for eccentricity will also change. The formula will now become A square is equals to B square 1 minus E square. So by putting the value we can find out eccentricity very clearly, that is 9 is equals to 25 1 minus E square. I know that E square will be 1 minus 9 by 25, that means E square is actually 16 by 25, or E is actually plus minus 4 by 5. Obviously eccentricity cannot be negative, so our final answer is that it is eccentricity of this ellipse is 4 by 5. So this is it for the first part. I hope that you have understood all the terminologies and the general equation. Now in the next part we are going to study about how you can trace the equation of ellipse from anywhere. For example, if it's center except some other point, then how can we trace the equation of ellipse? In the next part we are also going to study about the auxiliary circle and its properties. Stay tuned.